Now, in this channel, I have one more channel. Name of the channel is SSSD Sciences. And this is new channel. Name of this channel is given Vishwasundari. Okay, anyway, there is a contribution of Miss Sangita Ghanti in making my lectures. So that's why both names are appeared. My name and her name appeared in all the videos. This lecture is suitable for engineering students, whether it is diploma or graduate engineering, for higher secondary level also. This is a common problem, but very interesting. It is a problem on mechanics. Mechanics has two parts, you know that. First part is statics, second part is dynamics. And in dynamics, the first chapter is on rectilinear motion, means motion along a straight line. Acceleration may be present or may be absent. So we are going to start a problem on rectilinear motion. There is a tower. There is a tower, vertical tower, okay? And height of the tower is given, it is 120 meter. Say this is the tower. Okay? This is the tower, this is the ground. This is ground, okay? This is ground, and height of the tower, this is given. Height of the tower is given, it is 120 meter. 120 meter, okay? 120 meter, this is the height of the tower. So, in the given problem, it is mentioned that from the top of the tower, one stone is left, just left, means without any initial velocity, means zero initial velocity. One stone is just left, okay? And just after this, after 2 seconds of leaving this stone, one more stone is thrown in the upward direction with an initial velocity of 20 meter per second. 20 meter per second. Okay? One stone is thrown in the upward direction. Just after leaving this stone from the top of the tower, just after 2 seconds, one stone is thrown in the upward direction with an initial velocity of this much, 20 meter per second. Question is, where and when both the stones will meet? That is the question. Where and when? Where means distance and when means time. So where and when both the stones will meet? That is the question. So to solve this problem, let us assume that somewhere here they will meet. Both the stones will meet. This stone is coming in the downward direction and this stone is going in the upward direction. So somewhere here on this height they will meet. Say this height is denoted by x. Okay. This height is denoted by x from ground. From ground this height is denoted by x where they will meet. So obviously from the top of the tower, what will be the height? Since total height is 120 meter, so this height is 120 minus x meter. Right? 120 minus x meter. Now, three equations are known to you. You know that all these equations. S is equal to ut plus half at square. You know this equation? Then v is equal to u plus at. Then v square is equal to u square plus 2at. Three equations are required to solve for rectilinear motions, problems on rectilinear motions. So in our case, only this equation is sufficient to solve the given problem. Here, s is displacement, u is initial velocity, t is time, and a is acceleration. A may be retardation also. When a is retardation, instead of this plus sign, you have to write minus sign. Now, for this stone, which is going in the downward direction, it has zero initial velocity. Okay, so this u for this stone becomes 0. and s will be replaced by what? It will be replaced by 120 minus x, this height. Okay, 120 minus x. We have assumed that somewhere here both the stones will meet. So for this stone, the required equation will be 120 minus x is equal to, this part is 0 because u is 0, initial velocity is 0, and since it is going in the downward direction, so acceleration is present. Acceleration due to gravity, that is positive. Okay, acceleration is present. So positive sign will be there. So half and acceleration will be replaced by g. G means acceleration due to gravity, small g. And say time required is t. Okay, so half gt square. This is equation number 1. This is for the stone which is coming in the downward direction. Now think about the stone which is thrown in the upward direction from the ground with an initial velocity of 20 meters per second. So same equation we are going to use for this stone also. Okay. So here displacement s will be what? Displacement will be this much, x. So x, this is x, is equal to, initial velocity is how much? It is 20. So u is 20, right? U is 20. T is how much? T is not equal to t for this stone because it was thrown after 2 seconds. So for this particle or for this stone, t will be equals to t minus 2, not t. It will be t minus 2. T minus 2, right? Then instead of plus sign, minus sign will be there because it is when it is going in the upward direction, retardation is acting, means negative acceleration is acting on the stone. With time, velocity will go on decreasing. That means retardation is present because it is going in the upward direction. So here it will be minus half, a will be replaced by g and t will be replaced by t minus 2. And this is equation number 2. Here g is known. 2 unknowns are there, x and t, and number of equations are 2. So this is solvable. Number of equations is 2 and number of unknowns is 2. So number of unknowns is 2. So therefore both the equations are solvable. So how to solve both these equations? So from here, from equation number 1, we are getting x is equal to half gt square minus 120. 120 minus half gt square from equation number 1. So put that expression for x here in this equation 2. So from equation number 1, we are getting what? We are getting x is equal to 120 minus half gt square. Okay, x is equal to 120 minus half gt square. Say this is equation number 3. Right. Now put this expression for x in equation number 2. So from equation number 2, what we are getting? 120 minus half gt square. 120 minus half gt square is equal to, now expand this one, okay? So this is 20t minus 40, 20t minus 40, then minus half gt square, then minus 4t, 2, so plus 2gt, and then plus 4 will be there, so minus 2g. Now this minus half gt square appears in both the sides, on both the sides, so they are cancelled. So result is what? Result is 120 plus 2g is equal to 20 plus 2g into t. Therefore, t is how much? T is equal to 2 is common on both sides, so it will be 60 plus g divided by 10 plus g. 60 plus 9.81. Value of G is 9.81 meter per second square. And by 10 plus G, so 10 plus 9.81. And result is how much? It is written here. Result is 3.52 second. 3.52 second. This is time, so unit will be second. So 3.52 second. So this is the first answer. When they will meet? They will meet after 3.52 second after leaving the stone from the top of the tower. Okay. So that is 3.52 second. Next, how you will get x? X you will get from equation number 3. So from equation number 3, we are getting x is equal to 120 minus half gt square. So half 9.81 into this 3.52 second square. 3.52. So result is x is equal to, it is 59.22. 59.22 meter. So this is the answer. So from top of the tower, from bottom means from ground, from ground at a height of 59.22 meter, both the stones will meet. So this is the solution of the problem. Solution of the given problem. Okay. This problem is very interesting and very common. Okay, only I have used this equation. This equation is only required to solve the given problem. If you understand the given problem properly, then I think all the problems of rectilinear motions are solvable by all the students. If you know the proper use of this equation, then only it is possible. Okay? In the next class on this subject, physics, I'll show you one more solution on the from the same chapter, that is rectilinear motion. Okay? Thank you.